first lecture of section 2.4. We will discuss section 2.3 when I get back next week. We're not going to omit it completely just from this discussion for this week. This is a rather short section. It involves two rules, the product rule and then on the next slide the quotient rule. So we're going to take a look at this product rule and just kind of identify some information about it. For instance, we've got two functions, f of x and g of x, and we're multiplying those together. Take a look at what happens with the f of x. I'll highlight it in yellow here. When you take the derivative of the product of two functions, notice that we are multiplying in the first term. We've got the product of two items, one being the first factor, and then the derivative of the second factor, plus, and then we use the derivative of the first factor and multiply it times the second factor, which is the second function. We then take a look at, let's look at g of x, and notice that we do in fact have g of x in both of these, but in the first one we're looking at the derivative of it, and in the second one we have just the function itself. So in both of these we have the product of both functions, but we use the function of one times the derivative of the other, and we switch then which one we have the derivative. Now this rule can be extended to more than two factors. We have here f of x, g of x, and h of x, and notice that in these I'll just highlight function f, that in the first term of the derivative we take the derivative of f of x and then g of x, h of x, plus, and then we have the derivative, or this function f with the derivative of g of x and then h of x, and in the last one we have again f of x, but now we take it times g of x and the derivative of h of x. So in each of these products here we have a derivative of one of the three. Now we're not going to encounter this very frequently. This may not come up in too many of our much of our work, so we're going to primarily focus on this simplified form of that product rule. So let's look at the first factor, or the first problem here. Now we could, from section 2.2, we could multiply these together and take the derivative as we did back in section 2.2. Let's practice though our product rule. So we're going to look at the derivative of g of x, and the rule is that we take the first factor times the derivative with respect to the input variable of the second factor, plus, and then we take the second factor times the derivative with respect to the input variable of the first factor. Now if you're looking back at the first slide and you say, well, on the rule it said we take the derivative of the first factor times the second factor. Remember that in multiplication it is commutative, so it doesn't make any difference in which order we multiply them. Also we're adding, and addition is also commutative, so it doesn't matter if we, as I did, I start with the first factor and the derivative of the second factor plus the second factor times the derivative of the first. Remember, as I said in section 2, we need to show using the derivatives, and especially starting with this section, and it becomes extremely important, that the first step is to show the derivatives that we're going to be using. So as I have shown here, I am showing you the derivatives that we're going to use. Now the second step then is to actually take the derivatives, or derive the derivatives, or simplify, whatever term you want to use. So we have x minus 4, and then the derivative of x plus 2. Remember, we take the derivative of the first term, so we have the derivative with respect to the input variable of x. plus the derivative with respect to x of the second term, plus x plus 2, and I'm going to erase my little second step here because we're not really doing that yet, because at this point I also then must take the derivative of this. So the derivative with respect to x of x minus the derivative with respect to x of 4. So we're still showing the derivatives in that line and in this line. Okay, now let's look at this. My first factor is x minus 4. The derivative of x with respect to itself, remember what we do is we take the coefficient, which is 1, times the exponent, which is 1, and we multiply it then times x to the 1 minus 1 power, because we always subtract 1, plus, and we can look at the derivative for this, and this would be 2 times, and if you look at this, I'll just remind you that 2 is the same thing as 2 times x to the 0. X to the 0 is 1, so we could say we're multiplying 2 times 0 times x to the 0 minus 1. If you recall, back in section 2.2, the derivative of a constant, which is 2, is always going to be 0, and this is going to show that that in fact does happen. Okay, so we have that plus, and let me put another bracket in here to complete the work that we did here. So this is the derivative of x, and this is the derivative of 2, plus, and now we have our plus x plus 2, so we're using this, times, and we have again the derivative of x, so that's 1 times 1, x to the 1 minus 1, minus the derivative of 4, and again that'd be 4 to the x times x to the 0, so we have 4 times 0, x to the 0 minus 1. And so our second step, which we just did, was to actually take the derivatives. Okay, so the first step is to show the derivatives we're going to take. The second step is to actually take those derivatives. And the third step is to show at least 2 algebra steps. At least 2. Okay, so we have x minus 4, and then this is going to be x to the 1 minus 1 is 0, so this would be 1. This is going to be plus 0, which we really don't need to write, but we're going to show it just for now. Plus, here's our adding, x plus 2, and inside here we'd have 1, and this would be x to the 0, so this is just 1, minus, and again we'd have a 0 over here. So we end up with x minus 4 times 1 plus x plus 2 times 1, and I would expect you to simplify this to be 2x minus 2. So again, going down through the steps I expect you to show me. One is to show me the derivatives we're going to take. The second step is to actually take the derivatives, and the third one is to show at least 2 algebra steps. Now don't feel like you have to only take 2. You know, I expect you to carry them on into a reasonable finish such as this. Okay, so what we have then, let's go back. Are we finished? It says determine the derivative at the point 4, 0. Now just to remind you, this is our derivative, 2x minus 2, and this is a function whose output is the slope of a line tangent to a curve at a point. Okay, so this yields us the way of finding those. We want to know what is this at a point, or at the point, for 0. So we have the derivative of 4, and this would be 2 times 4 minus 2. 2 times 4 is 8, minus 2 is 6. So the slope of the tangent line at the point for 0 on our curve, on our graph of x minus 4, the quantity, times x plus 2, would in fact be 6. Now I said that there was another way we could write this, so let me put that in green. The alternate way would be to take, let's see, g of x is, again, x minus 4 times x plus 2. Let's use FOIL. First terms, x squared. Outside terms, 2x. Inside terms, negative 4x, so that's negative 2x. And the last terms would be negative 8. Now, if we look at the derivative of that, we'd have the derivative with respect to x of x squared minus the derivative with respect to x of 2x minus the derivative with respect to x of 8. And our derivative of 2x would be 2 times the leading coefficient of x to the first power minus, and the derivative of 2 would be 2 times 1 with x raised to the 1 minus 1 power minus the derivative of 8, which would be 0. So our answer would be 2x minus 2. Does that compare? Yes, it does. That's a little faster because we are just having to expand the product of the binomials and then take each individual one. So this is an example of one where we can in fact use our product rule, which is what we used up here, but it would be a little bit easier to just use the expansion on that. Okay, if we look at this on a the graph rather, pick up a graph page, and we're going to multiply. So I'm going to insert the factors of x minus 4, and we're going to multiply with then the factor of x plus 2. And if we're looking at the point 4, we would then put a point on, and I'll just put the point there. I'm going to change the value of that, and then we'll draw a tangent to that at that point. And if we are looking then for the slope of that, we'll go in here to measurement, look at the slope of that line, and the slope of that line is 6. Does that compare with what we had? And the answer is yes. The slope of the tangent at the curve is equal to 6. Video for section 2.4. We're going to look at another problem just to make sure we're understanding this. So I'm going to give you the function f of x equals the square root of x times the quantity x cubed plus 1/4 x squared. Again, we could do a multiplication through this, but let's practice the product rule again. Before we start, though, I'm going to write the square root of x as x to the 1/2 power, and then we can work with this problem. Okay, so the derivative is the first factor, so x to the 1/2, times the derivative with respect to the input variable of the second factor plus the second factor, 1/3, or x cubed plus 1/4 x squared, times the derivative with respect to x of the first factor. So we have x to the 1/2 power times, and the derivative of each one of these terms, so the derivative of x cubed plus the derivative with respect to x of 1/4 x squared plus our second factor, and then the derivative of x to the 1/2. Now we can go ahead and take that derivative. We would take the exponent times the leading coefficient, and then we're going to subtract 1 from that exponent. Now at this point though, we've only taken one derivative and we have two others to take, so we need to go through and do that work. So x to the 1/2 power. The derivative with respect to the input variable x of x cubed is going to be 3 times the leading coefficient, the exponent times the leading coefficient, times x to the 3 minus 1, plus 1/4 times the exponent times x to the 2 minus 1, and we'll finish up then by repeating what we have. X cubed plus 1/4 x squared times 1/2 x to the negative 1/2. Okay, so we have our first step. We're showing all of the derivatives we're going to take. The second step, we have actually taken the derivatives, and now we need at least two more algebra steps. So here we have x to the 1/2 power times 3x squared plus 2 times the 4th would be 1/2 x to the first power plus, and we're over here now, x cubed plus 1/4 x squared times, and remember we're always wanting to write our terms with positive exponents only, so this would be 1 divided by 2x to the 1/2 power. Now if there is anything else we can do with this, we'll take a look and see. There does seem to be an x in each one of these. We might be able to successfully factor out an x. So we could have, let's say, x to the 1/2, and then we'll factor out an x from this portion. So we have 3x plus 1/2. And we can factor out an x squared from this portion of it, and we would have x plus 1/4. And when we multiply then, the other portion we'd have times 1 divided by 2x to the 1/2 power. Not a lot more we can do with that. I don't see any common factors. The only thing I can think of would be to say at this part we'd have x to the 1/2 plus 1, that would be 3/2 power, and then 3x plus 1/2. At this part, I could look at, I have x squared and I have x to the 1/2, so I could look at this as x plus 1/4, and if I subtract 1/2 from 2, that would give me x to the 3/2 power, and this would all then be divided by 2. Now it's a problem like this that we probably should go back and check on the inspire. So let's take the inspires. Let's pick up a calculation page. We're going to go back to our original problem here, and I am wanting to, I think the first thing I'll do is to define that function, and so we'll define f1 of x to be equal to I'm going to move this down so I can see that a little better. It's going to be the square root of x, and I'm going to make sure I move outside the square root sign there, times the quantity x cubed plus, and I will make this 0.25 since 1/4 is the same as 2500ths, x squared. And I'm just going to say enter. Now there are some things that we can do. Remember, we can go to menu and down to calculus and derivative. The variable, input variable is x, and tab. And the advantage of having defined it first is that if we want to graph it later, we could do that. I can refer to it by name, f1 of x, and we end up with, oh my, that looks a little different than what we had, so we're going to check it and see. If I use an up arrow and I say, is that the same thing as the answer that we got? So let's go down to our answer. And I'm going to put in x to the 3/2 power, so x raised to the 3/2 power, times 3x plus 1/2, so I'll set a parentheses, and 3x plus 1/2, and move outside of the parentheses. And then I have a fraction, so I'm going to insert a fraction here. And let me back that up and make sure that I get the plus in there. There we go. And insert a fraction. I have x to the 3/2 again, so x raised to the 3/2 power. Times the quantity x plus 1/4. So we'll have x plus, and I am going to make that 0.25, and I divide that all by 2. Remember, if these are equivalent, I should get the word true. So here we go. Enter, and there's that word true. So our answer looks a little different than what we had before, but our answer is also correct. Okay, now comes the next major rule of this idea in this section. It's called the quotient rule. So let's take a look at this. A quotient, because we have the rational function of a function divided by a function. Let's take a real close look at this and see where each of these occur. Here is my numerator. And notice that in the first quantity of my derivative, I take the derivative of that numerator. I subtract, and then I multiply the function times the derivative of the denominator. So my numerator begins in the first term, I take its derivative minus, and then the other term, I just use the function itself. Now, let's take a look at the denominator. So we have the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, and we are going to then have all of that divided by the square of our denominator. Now this is one of those rules where it's very easy to get tripped up on it, so I'm going to try and give you a couple of ideas on how to remember this. In a fraction, you have what's called a numerator. That's the top part. And we have then the denominator. That is in the bottom half of that fraction. When we start our quotient rule, which of these do we start with? Well, we start with our denominator, and d comes before n, so we start with the denominator. And so we have the denominator times the derivative of the numerator minus, and then we just switch the order, numerator times the derivative of the denominator. So that will help you to get started. We always start with which of these comes first, which is denominator. The other thing that is always a question in minds is, do I add or subtract? Well, let's go back and let's look at this product rule. In the product rule, we are adding. If we have two terms of the same base and we multiply them together, what do you do with the exponents? Yeah, we add them. So if that helps, you're multiplying. The product rule is multiplying, and we add between, just like we do when we have terms of the same base. Well, let's go to our quotient rule again. When we have terms of the same base and we divide, what do we do with the exponents? And we subtract. Okay? Hence, this is a quotient rule. So we have fractions or functions in a fraction format, and so we are subtracting. So that would be one way. The other way is sometimes we have some other ways of remembering things, and you might have seen this before, but I'm going to look at it this way. Suppose that my numerator is high and my denominator is low. Then the derivative of this goes like this. Low, d high, d standing for derivative, minus high, d low, standing for the derivative of the denominator, divided by denominator squared. So you could kind of make a little game out of it and say it's low d high minus high d low divided by low low. So again, if you want to use that, feel free to use it. If not, then you find your own way to remember how this rule goes. This is one of those things that you do want to have memorized by the time we take a quiz or a test on it. Okay, well, let's try this and see. We're going to take the derivative of y with respect to the input variable x. We're going to start with our denominator, x minus 1, and we're going to multiply by the derivative of our numerator, minus, because we are dividing, our numerator times the derivative with respect to x of our denominator. Okay, all of that divided by the square of our denominator. So we have shown now, this is the step showing, so this is the one we show the derivatives. Okay, our second step, we will now take the derivatives. I'm going to have that be the beginning part now of our third video for this session. Third video for section 2.4. The first step was to show the derivatives. The second one is to actually take the derivatives, although when we look at this, we still have other derivatives to take in here. So we have the derivative with respect to x of the x squared, minus the derivative with respect to the input variable x of the second term, 4x, plus the derivative with respect to x of our constant value 3, minus, so we're at the subtraction sign here, x squared minus 4x plus 3 times the derivative with respect to x of x minus the derivative with respect to x of 1, all of that divided by the square of our denominator. Okay, so we need now to take these derivatives, all of them at this point. So we have our x minus 1, that's a factor here. The derivative of x squared is 2 times our leading coefficient. So 2 times 1 is 2, and we subtract 1 from our exponent. Minus the derivative of 4x would be 4 times 1 would be our exponent, and then we subtract 1 from our exponent, which gives us x to the 0, plus the derivative of a constant function, as we've been seeing, is 0, minus x squared minus 4x plus 3 times the derivative of x. So we have 1 times our leading coefficient x, and then we would subtract 1 from the exponent, giving us x to the 0, minus the derivative of a constant is 0. All of that divided by x minus 1 quantity squared. So this is step number 2, where we actually take the derivatives. And again, you then need to show at least 2 algebra steps. Okay, so let's see. We've got x minus 1, and this will reduce down to be 2x minus 4 minus, and we have our x squared minus 4x plus 3 times 1, all of that divided by x minus 1 quantity squared. Okay, that's one algebra step. Let's see what we can do here, if we can clear this up just a little bit. If we look at, let's say, multiplying these two together, we'd have 2x squared, and we have negative 4x minus 2x, that's negative 6x. Negative 1 minus 4 is plus 4. Then we go on, here's our subtraction. And I recommend, well, we only have 1 actually. We multiply times 1, we still get x squared minus 4x minus 3. Be careful about that subtraction. It's going to be negative x squared plus 4x minus 3, all of that divided by x minus 1 quantity squared. We can collect some like terms, and I would expect you to do that. So 2x squared minus x squared is x squared. Negative 6x plus 4x is negative 2x, and 4 minus 3 is 1 divided by x minus 1 quantity squared. Now the next step I would expect you to do is to, can we simplify this last step? Can we factor that? And as it turns out, yes we can. It's going to be x minus 1 quantity squared divided by then our denominator, and it turns out to be equal to 1. Now what does this tell us about our original function? Well, again, this is a function. This is telling us the slope of a line tangent to the curve at any point, and since this turns out to be a constant, it would mean then that regardless of the point, a tangent line, or a line tangent to the curve will have slope 1. Let's take a look at this problem. Let's see what this looks like. So let's go into another graph page, and we're going to put in the fraction that we started with. Let's see, this was x squared minus 4x plus 3, and that's divided by x minus 1. Turns out that our function is actually a line. Now how can that be? Well, we didn't look to see, could we factor x squared minus 4x plus 3? And if we factor that, what would that be like? So I'm going to go into adding another page, a calculator page, and I'm going to go to Menu and Algebra and Factor. And I'm sure we could do this in our heads, but I want to show you, make sure you understand you can do this. X squared minus 4x plus 3, and be sure you put comma x. That's telling the Inspire that your input variable is x. And when you factor that, sure enough, we get x minus 3 and x minus 1. On our graph then, what would happen at 1? Well, at 1, remember, it is not a part of our curve. In fact, if I go in here and attempt to place a point at 1, it's going to tell me that it can't be done. So we will do the same thing that we have done in the chapter on limits. We'll go in here and just make it be as close to that as possible. So there it is. But we have to remember that we have to change the attributes of that point, and we'll change the attributes of that point to be something of an open circle. Oops, let's try that one more time, and I'll make sure that I get that there correctly. Okay, so we'd have an open circle there. Okay, let's go on to the next problem, and the next problem says find the derivative of this function. Now if you look at this function, we have a product going on. We can work this as a product, but when you get to this part, you're going to have then a quotient to work with. We could multiply this x to the 4th into here. That might simplify our work a little bit. We're still going to end up though with a quotient, but at least we'll eliminate having the product as well. So look to see what algebra you can take care of before starting the problem. It may help you to avoid using one of our product rule or quotient rule. Okay, so let's look then at our derivative for this function. We've got the derivative with respect to x of x to the 4th, and that's, we'll call that a standalone function, minus, and when we get over here, we're going to have to use the quotient rule. So here we go. We have our denominator times the derivative with respect to x of our numerator minus our numerator times the derivative with respect to x of our denominator. And this is a fraction that we need to remember to place this entire fraction over the square of the denominator. So I'm going to change the subtraction sign just a little to make sure that we understand that it's subtracting the entire fraction. Now, I've shown you the derivatives we're going to take, so now the next step is to actually take the derivatives. So the derivative of x to the 4th is 4 times the leading coefficient, which is 1, x to the 4 minus 1 power, minus, and then we'll take a look at our fraction here. We've got x plus 1, and then our derivative of 2x to the 4th. Again, we take our leading coefficient times our exponent and subtract 1 from our exponent, minus 2x to the 4th times the derivative of this term. So the derivative of x is 1 plus the derivative of 1 is 0. All of that divided by x plus 1 quantity squared. Continuing on, we have 4x cubed minus, and then we have our fraction again, so we have x plus 1 times the quantity 8x cubed minus 2x to the 4th times 1, all of this divided by x plus 1 quantity squared. Okay, so we show all the derivatives we're going to take. We actually take the derivatives. We've got a couple lines now of algebra. This is one of them, but let's see What else we might be able to do? Let's combine the terms in this numerator. So we have minus, and this is our fraction now. Let's see if I can get that line a little better. Okay, so I'm going to have, let's see, this is going to be 8x to the fourth plus 8x cubed minus 2x to the fourth, and that's all divided by x plus 1 quantity squared. Okay, there's not, well, there's some terms we can simplify here, so let's take care of those. 4x cubed minus, and looks like we're going to get a 6x to the fourth plus 8x cubed divided by x plus 1 quantity squared. Other things that we can take care of that are relatively easy here would be to, we can factor out a 2x cubed, leaving us with, let's see, that's 3x plus 4. And the reason we would want to do this is to see if we could somehow cancel a factor, which we cannot. So we end up then with this as our answer. Now remember, what we have here is, this is a function whose output is a slope of a line tangent. Now let's see if I can clean this up a little bit. Of a line tangent to a curve at a point. We don't know which point it is, but to a point. How can we check our work? Again, we can put this into the Inspire, find the derivative using our derivative functions in the derivative, and then set it equal to this. If we get the word true, we know we've got it.